This graphics card is not even 2 years old, and in theory it should be in very good, even excellent condition. However, it is not at all.
Say that you're fine when you're not really fine, but you...
It's not like it's damaged or neglected. From the outside, you wouldn't even say there's anything wrong with it. Even while playing, at least at first, everything seems to be okay. But after 5 or 10 minutes, the fans start spinning ominously and stay at high speed. You might be thinking,
what do you expect? It's a powerful card. It always runs like that, it has to run like that. But I'll say that's nonsense.
Right? Although sometimes it might seem that way to us, because the degradation of thermal paste or thermal pads doesn't just happen overnight. And it's a process that usually takes several months, so we slowly get used to it not running as well. That's why it doesn't matter if you've had your card since it was new, or if you've just bought one, or even if you're planning to buy a used one. It doesn't even matter how old or new it is. Replacing the thermal paste or thermal pads can significantly improve how even a new card runs. Manufacturers sometimes cut corners on this, just read about it. And even if they use relatively better pads and paste, they're still not completely resistant to the effects of time. And as weeks and months go by, and with each heating cycle, they dry out, reducing the efficiency of heat transfer in the process. It's simply material fatigue. And just like we should change the oil in a car engine, we should also replace these components.
He didn't know.
Now hold on, because here come the specifics. Before replacing the thermal paste, the GPU of this actually pretty well-maintained card was at 76 degrees Celsius. But the hotspot, meaning its hottest point, was already sitting at a lovely 3-digit number. That's right, over 100 degrees Celsius. How the hell? As you can imagine, the fans were screaming bloody murder. After performing the procedure I want to teach you today, the temperatures dropped accordingly to 64 and 77 degrees. As you can guess, the fan noise also dropped to a level I don't even remember from when it was new. The frame rate in games also increased. That's why this is a must-watch for every dedicated graphics card owner. Newer, older, it doesn't matter. This is Pavel, and you're watching the TechManiac HD channel. Welcome! You can watch this video thanks to the support of the GFG GVG Mall platform. It's a huge specialty store. They specialize in keys for games on PC, Xbox, PlayStation, and even Google Play. You can get practically everything here, from Steam gift cards to software like Office or Windows. If you're still struggling with that annoying message reminding you to activate, then visit the link in the description right now. You'll receive the purchased key within a few minutes, and all you have to do is paste it into the activation settings. This will not only make your copy of the system genuine, but also allow you to upgrade to Windows 11 without any problems. You'll activate Office and assign it to your account in just a simpler way, and with the code TMHD, you'll get an extra 20% discount, which can go up to 30% during various holidays and events. Stop overpaying and visit the website now. In this episode, we'll be restoring graphics cards to their former glory. I'll be doing this operation on an RTX 3090 from FA2 as an example. However, no matter what card you have, the steps are almost identical everywhere, and I'll do my best. It's worth doing it in such a way that you can complete the operation without complications or difficulties. Before starting the procedure, it's wise to record your graphics card's operating parameters for later comparison. Play a game you like, or work for a while in the program you normally use. Write down not only the temperature of the graphics processor or the fan speed, but also include data such as how much power the card is consuming. You will only find the GPU hotspot and VRAM hotspot temperatures in newer models. The speed of the case fans and the room temperature also affect the results achieved by the card, so it's worth noting them down as well. But that's only if you want to thoroughly analyze and compare all the data later. If you want to go all out, you can also write down the GPU clock speed or calculate the average number of frames achieved. If your card is noticeably louder or has moments when the fans significantly ramp up their speed, then this is something for you. Suffice it to say that after performing the operation, while keeping the same operating parameters, the hotspot temperature dropped by 25 and in some applications even by 30 degrees. Although we're focusing here on the graphics card itself, for the sake of formality and what this material is about, I should also mention the need to keep both the inside and outside of the case clean. Remember to use the appropriate vacuum cleaner attachment to clean the intakes, dust filters, and the fans inside the computer as well. You might not need to vacuum the inside that often, but from time to time, at least clean the surface of the graphics card fans, the CPU fan, and don't forget about the power supply. Dust also accumulates there, which over time turns into a thick layer that heats up the components. Vacuuming is something we really should do from time to time, but even if we keep our equipment in relatively good condition and clean, the graphics card itself requires more attention. Just because we thoroughly vacuum or even blow it out with compressed air from the outside doesn't mean we'll get rid of all the dust. Not completely. As you can see, the dust still sticks around the fans and on the blades themselves, which might not matter much, but worse, it also coats the fins, which does negatively affect the ability to dissipate heat. In this video, I'll show you how to clean the cooling system to get rid of dust even from the hardest to reach places. However, that's just a side note, because the main topic of this episode is replacing the thermal paste and thermal pad, so let's finally get to work. Prepare an appropriate workspace and tools. Links to equipment that might be useful for you to perform this procedure, such as an anti-static mat, magnifying glass with a lamp, isopropyl alcohol, or thermal paste, as well as thermal pads of various thicknesses, can be found in the description below this video and in the pinned comment. For those who want to be extra careful, I'll also include a link to latex gloves there, although I personally don't like working in them. It's definitely very important to choose the right screwdriver or its tip that will fit perfectly with the screws in your card. After all, you don't want to strip or damage the screws and end up making it impossible to disassemble the card later because of a screwdriver that doesn't quite fit. That's why in the description I'll leave a link not only to my small and handy set, but also to something bigger and much better. Before you start unscrewing anything, take a close look at every inch of the card, searching for both small and large screws. These can be located not only on the back, the front, or somewhere in the middle, but also on the bracket, and although getting inside doesn't always require removing them, it depends on the construction itself, it's better to unscrew a few more screws than one too few. So give yourself as much time as you need to analyze and plan your course of action. Some fans are screwed to the cover or directly to the heatsink, and it's usually a good idea to unscrew them first, because during maneuvers and repeatedly turning the card, there's a risk of damaging them. If we grab it wrong and our finger presses too hard on the blade, good quality plastic won't give in, but if it's made of poor quality material or is already a few years old, it can definitely break. So please be careful with the fans, because even if you don't break them, bending them also puts too much stress on the electric motor shaft, which can lead to damage, not necessarily right away, but over time it can definitely contribute to it. Fans are, of course, consumable parts and can definitely be replaced. Even without our interference, they can simply fail on their own, but fortunately, getting a new set of fans for any of the more popular series of cards is definitely possible. In the case of the RTX 3090, which we're working with today, removing the fans, or rather the entire shroud, isn't an easy first step. The screws are located in the middle, and even with a relatively thin screwdriver handle, the angle of approach is too wide to unscrew a tightly fastened screw without damaging it. As a result, I'm forced to start the procedure, by removing the backplate, which protects the back of the card. As with disassembling anything even slightly more complicated, remember to check the length of each screw and sort them in designated places while keeping them in order. This will make reassembly much easier later on. While I'm at it, I'll also unscrew the screws that press the heatsink to the graphics processor. Remember to first slightly loosen them diagonally and then gradually unscrew them bit by bit. In theory, this evenly reduces the pressure on each side of the silicon, which, after all, is a really fragile processor. Although in this model it is surrounded by a protective metal square ring, it's still a good habit to be cautious this way. Going back to the backplate, it usually serves an aesthetic function, and on heavier cards, it also adds structural support. But in the RTX 3090, this solid piece of metal also helps dissipate heat from the VRAM chips. As you can see in this particular model, removing it requires a moment to figure out. After lifting it, we can see that some of the thermal pads stayed on the backplate, some are still on the memory chips, and another piece got torn and frayed. That's why every time we take apart the card, we should always keep in mind that replacing the thermal pads may well be advisable. Although we'll come back to this topic when we fully disassemble it, because it's on the GPU side where most of the thermal pads are located. However, to get there, we need to separate the PCB from the cooling system, and that means this is the moment when we should disconnect the power cables for the fans or the RGB lighting. Here as well, we avoid sharp metal tools. It's best to use plastic for prying, although we have the most control with our fingers. At the same time, the likelihood that something will slip and fly off too far is minimal, so if possible, use your fingernails. In the next step, gently pull the circuit board away from the card's cooling system. Remember to hold it firmly, because when the strong bond of the thermal paste and thermal pads releases, it can spring back. Applying less pulling force but maintaining the tension for a longer time also minimizes this effect. If you're having trouble separating these two parts, make sure you haven't missed any screws. You can try making a slight twisting motion in both directions, but remember that turning too much can damage the thermal pads. Another effective way to weaken the surface bond is by heating, either by intense gaming and quickly disassembling the card, or by warming up the heatsink with a hairdryer. After removing the cooling system, you'll see what actually makes up the graphics card. It's only slightly larger than a standard mailing envelope. In the case of the design you see here, the cooling system makes up more than 90% of the weight, and that's what we should focus on now, especially the thermal pads, because removing the PCB finally allows us to properly unscrew the screws from the shroud with the fans. If your case is equipped with good dust filters and you take care of your equipment, there's a chance your heatsink will look as clean as mine. Here you'll only find the tiniest bit of dust stuck to the fan blades and around them, which can be easily removed with a cotton swab soaked in isopropyl alcohol. However, if your card hasn't been dusted off even on the outside for a long time, then after removing the fans, it might look more like what you see now in one of my old recordings, where I used the card for a while without any filter in the case. It's best to blow this dust out with compressed air or vacuum it using a special nozzle with long bristles, which will help loosen the compacted and settled dirt between the cooling fins. You can clean the fan blades from the inside in the same way, but during this process, don't let the fans spin freely. Too high a speed can cause damage to it. Simply hold the fan in place to keep it from spinning. Once the cooling system has been restored to perfect condition, we can return to the topic of thermal pads, and as we can see, some of them have remained on the heatsink. The thermal pads in my card have indeed been in use for almost 2 years now, and as you can see, the pad itself looks rather dried out. This doesn't necessarily mean that we always have to replace all the pads in every situation. After all, they're not cheap, and working with them is probably the most labor-intensive part. That's why if they still retain their elasticity and seem moist, almost as if they're coated with oil, you can keep using them for a while longer. Although I'll leave the final decision up to you, because from an economic point of view, replacement may not always be worth it, especially if the manufacturer used higher quality pads, although it's rather hard to verify that just by looking at them. However, I decided that since the card has already done its job, and it's a top model equipped with 24 GB of GDDR6X memory, which is indeed extremely fast, but as a result also extremely hot, so such a replacement would definitely be justified. If you decided to keep the old pads, you can skip this step, although since you already have everything exposed, it's worth measuring them. Just in case you want to replace them in the future, you'll already know how many and what thickness of pads you need. To do this, peel them off the surface. If the pads are already worn out and dried up, this procedure might be a bit more difficult. Under no circumstances should you pry them off with a screwdriver or any other metal tool, because you could damage the memory module itself. My blue mat, which is linked in the description, came with various plastic tools for prying things apart and disassembly. I'm going to use one of them, although you can use a guitar pick or something similar. Next, measure the thickness of all the thermal pads with a caliper. Yes, all of them, because they're not always the same thickness. Even 0.5 millimeter more or less can make a huge difference. From my measurements, it turned out that all the pads on the memory modules are 1.5 millimeters thick, but with minimal pressure, they easily go down to even 0.8. On the other hand, the ones that take heat from the power section are 1 millimeter thick, so which pads and paste should you choose for replacement? I'll be honest with you, I really like experimenting with different solutions, both cheaper and more expensive ones, which you can easily notice from my videos. However, here I'm going with a proven solution. Maybe in the future I'll make a video testing different thermal pastes and pads on a graphics card, so subscribe to the channel, but for now I'm choosing something that may not be the cheapest, but is definitely good, if not the best. Of course, I'm talking about the solution from Gelid, or as some say in Polish, Gelit. Their GC Extreme paste has proven its excellence many times. And more importantly, from my tests, after a year or two, the drop in its thermal conductivity is absolutely minimal. Which can't be said about many other pastes that can lose their properties even a few weeks after application. When it comes to pads, I'll also stick with the same brand, choosing the GP Ultimate product, which has a thermal conductivity of 15 W per mk. The GP Extreme pads are a bit cheaper and have a lower thermal conductivity of 12 W. Their biggest difference is the hardness and how easy or difficult they are to compress. The higher thermal conductivity of the GP Ultimate pads comes at the cost of being harder to compress than the GP Extreme, which is quite important, especially in graphics cards. If we use a pad that's too thin, there won't be any contact, which is self-explanatory. Using a pad that's too thick and hard to compress can push the heatsink away from the GPU, which will definitely have a negative impact on its temperatures. And since it's usually recommended to use a pad that's a bit thicker than the measurement might suggest, it's worth considering a slightly thicker GP Extreme as well, keeping in mind that it will be slightly compressed compared to the GP Ultimate. Besides, getting two different thicknesses of pads right away can save you some trouble. You can find all the links to the sorted pads by length and type in the description and in the pinned comment. But before we move on to the step of cutting and sticking the pads, we first need to properly prepare the surface. The GPU core, as well as its surroundings, will be smeared with old thermal paste. Let's start by softening it with a paper towel soaked in isopropyl alcohol. There's a link to the right one in the description. Don't use toilet paper, as it's too fragile and falls apart too quickly. This way, remove the paste, but only from the center of the processor. Be careful around the edges, because you can chip them if you catch them with the towel. It's best to do precise cleaning of the GPU using a cotton swab soaked in the same alcohol. Actually, the surface of the processor is the most important part here, and it needs to be spotless. If a bit of old paste remains between the capacitors, it's not a big deal. Of course, whatever can be easily removed, we should definitely remove, but let's not go overboard. Digging it out from between the capacitors isn't easy at all, and pressing too hard could eventually damage them. Once the graphics processor is relatively clean, gently remove the old pads. In my case, the ones on the MOSFETs of the power section were already too overheated and, as a result, too dried out to remove them gracefully. No matter which side I tried to remove them from, they crumbled terribly, which only reinforced my belief that ordering and replacing the thermal pads was a good idea. Cleaning all of this took me 45 minutes or so, and it was like scraping with a plastic spatula, cleaning. 24 memory modules was much more pleasant with a magnifying glass equipped with an LED ring. Yes, cleaning the MOSFETs without it would have been quite a challenge, especially at night. It's worth checking if we haven't missed any small pad, because that can happen. When all the surfaces are free of solid particles, wipe them with a paper towel soaked in isopropyl alcohol or a cotton swab. Don't forget to clean and remove the pads from the heatsink as well. It's easy to overlook if you're fully focused on the PCB itself. On the other hand, if there's dust on the card's PCB, don't wipe it off with any cloth or paper. Use an anti-static brush for this purpose. You can also use it to clean the bracket where the video outputs are located. A link to a suitable brush that won't damage your equipment is also in the description. The process of cutting the pads to size is tedious and requires focus, but to save yourself some time and avoid wasting expensive thermal pads, it's worth having a sensible plan of action from the start. As you can see here, I'm measuring a section of 4 memory modules that are placed in a row, but there are 4 sections of the same size. 2 in the front, 2 in the back. In addition, I have 2 identical sections of 3 modules in a row and 1 single one. This way, I can cut 6 strips of the same length, 2 of which I shorten by the area of 1 module, plus 2 different strips for the power section. A utility knife and a cutting board will help us cut properly. The pads I'm using here have a thin plastic glued on both sides, which the sharp knife goes through smoothly. Thanks to this, we can cut and fit everything without unnecessary gluing, tearing, or leaving grease from our fingers on freshly cleaned surfaces. Sticking it to itself is much more pleasant. With a utility knife or, even better, tweezers, peel off the transparent protective layer and stick the pads onto all the memory modules and power sections that require it. With the pads still protected, you can apply fresh thermal paste without worrying about getting them dirty or snagging them. Although I tried to spread it using the included spatula applicator, it didn't go very well for me. I definitely prefer the soft, much bigger and wider jelly-gelled spatula that comes with the 10-gram paste. I'll leave a link to that one in the description. It was with this spatula that I spread a very thin, even layer over the surface. Now we remove the top protective layer from the pads with the printed labels. This part signals that the operation is nearing its end, but don't let your guard down yet, because there are still moments where you can make a mistake, just like I did here. Whoever should, write in the comments now what my screw up here is. Honestly and sincerely, without skipping ahead, this is your moment to pause and go to the comments section. 3, 2, 1, ready? In that case, I'll explain now. A beautifully prepared, refreshed PCB with fresh paste and new pads is heading towards an equally clean and ready heatsink. The heavy heatsink is at the bottom, the board comes from above, everything according to the rules, but where the heck did the shroud with the fans go? Oh my. As you remember, the board blocks reasonable access to the screws. This, let's call it a detail, cost me by having to repeat the same operation once again. Yes, along with wiping off that fresh but already disturbed thermal paste, I had to apply new paste once again, which I did painfully and late at night. For my dedication and care for your well-being, I only ask for a juicy like under this video and a comment. Just for the statistics, because they help the YouTube algorithm understand that the material is worth recommending to others. But let's move on, assuming that the cover with the fans is where it should be. Lower the PCB and stand over the whole thing, and through the 4 holes try to locate the mounting screw positions. Lower the board very slowly and carefully. A minimal adjustment, like shifting or rotating by a millimeter, is still perfectly acceptable, but if you don't align the screws with the designated spots, you'll have a problem. If you lift the board off the heatsink, unfortunately, you'll need to wipe off the thermal paste from the GPU and the heatsink and apply new paste. At least if we want to do the job properly. First, we loosely attach the screws that hold the heatsink to the GPU diagonally, and then, also diagonally, we slowly tighten each screw. This way, the pressure will be distributed evenly. We connect all the cables we previously unplugged and install the backplate in its place. After installing the graphics card, remember to connect the monitor cable. Seeing no signal can make anyone break out in a cold sweat. After starting the computer, constantly monitor the temperatures. Watch how they rise and how the fans behave. At first, the fans might not even spin, but that's because the temperature is much lower than before. Run something light, like browsing YouTube in 4K and keep watching. Later, test the gaming performance, also keeping a close eye on things. If something seems off, I can tell you that excessively high GPU temperatures usually indicate that the thermal pads are too thick. Excessively high temperatures on the VRAM might be a sign that the pads are too thin, and large differences between the GPU temperature and the hotspot could mean the thermal paste wasn't applied properly. So let's take a look at the results before and after performing the operation. Playing Cyberpunk 2077 in 4K resolution with ray tracing enabled is now much more enjoyable. The GPU temperature may have dropped by only 8 degrees, but the real problem was the hotspot, which has now been reduced by 20 degrees. The VRAM temperature increased by 2 degrees. But the reason for this is that, previously, due to the overheating GPU, the card's fans were spinning at speeds reaching up to 2300 RPM, but after this operation, the speed settled at around 1850 RPM. So, wanting to compare the results one-to-one, I manually set the fans to the same speed, which proved that not only replacing the thermal paste, but also replacing the pads achieved the intended result. The GPU temperature dropped from 76 to 63 degrees, the hotspot from 99 to 74, and the memory from 82 to 77.6. Here, please take a look at the results from testing with the Firmark program. Due to the slightly lower temperature, the automatic system maintained higher GPU clock speeds, which of course resulted in slightly better performance. We can conclude that the operation was definitely worth it, even for this card that's not even 2 years old. If you have an older card, the percentage gain could be much higher. Of course, that's not all you can do to fully optimize the performance of your graphics card. Because to extend its lifespan and additionally reduce the amount of heat it generates without losing performance, you should undervolt it, which doesn't require disassembling the card, and it's an operation you can easily do with my guide. Anyway, I'll explain everything in the next video, which will be dedicated to it. Remember to subscribe and visit the website www.techmaniash.pl so you don't miss that episode. Take care, bye,